What is going on, guys? My name is Amos and I'm back with yet another video. So in today's video we want to discuss the idea of limits in mathematics. All right, so let's get started. So to better understand this topic, I'm going to choose for you guys a very simple function. All right, and that function is going to be a polynomial function of degree 2, and that is also known as a quadratic equation. So let f of x be given by x squared minus 5. And now let's fix x at 3. So let's say x is equal to 3. And now let's not worry about the image of 3. That is, let us not take f of 3 yet. We are trying by all means to avoid that. Now let's consider values of x that are less than 3. And then that is in the first step. In the second step, we'll consider values of x that are greater than 3. And we're going to take the image. We're going to take their image. All right. And then now let's start with a simple value. Now let's say we start with f of 2.8. All right. F of 2.8 is 2.84. And f of 2.9 is 3.41. And let me now get really close to 3, and let me take f of 2.99, and now this is going to be equal to 3.9401. Now that's all for values of x that are less than 3. Now let's consider values of x that are greater than 3, that are strictly greater than 3. So let's take f of 3.05. Now f of 3.05 is 4.3025, and f of 3.5 is that is 7.25, and f of 4 is going to be 11. Great. So we have 6 different values of x. Now I'm going to help you guys with some arrows. Now here I'm going, for values of x that are less than 3, I'm going to help you guys with a down arrow, and for values of x that are strictly bigger than 3, I'm going to help you guys with an up value. Now this is going to help us identify the value of f of x that we are trying to approach, that is on either side of 3. So that is on the left side of 3 and on the right side of 3. Now if you carefully look at what we have here, we are trying to approach a certain value, and that value is going to be 4. Now that value 4 is going to be the limit of the function f of x as we try to approach 3 on either side. All right, now that is what a limit is. All right, let me just write that down. So now the description of whatever is written here can be expressed by using some notation. Now it's not very complicated to use this notation. You just have to, it's something that you have to keep in mind. So here we're going to say we want to take the limit of the function f of x. Now as x tries to approach, or as x approaches 3. All right, so now our value is going to be 4. We can also write this in another way. So we can say f of x goes to 4 as x goes to 3. Now that is what taking the limit of a function is. So we don't want to worry about what happens when x is equal to the value 3. We are interested in what happens when x tries to approach 3, that is on either side. Now this is a polynomial function, so we can take what is known as the left-sided limit and the right-sided limit, and all that is going to work. We'll more on that just in a few seconds. So that is what it is. The function does not have to be defined on at the point where x is taken as 3. All right, because we don't want to worry about that. We want to worry about what happens when we try to approach this 3. All right, so that is the idea of limits. Now let me just give you one example of a function where our value of x. Now for f of x, we know that the function is defined at 3. All right, now let me just give you an example of a function where at a certain specified value of x, the function is undefined. All right, Now let's look at the function f of x defined by sine x over x. Now before you guys scream at me, let's consider the limit as x goes to 0 of the function sine of x over x. All right, now you guys might start screaming and say, all right, sine of 0 is 0 and x is 0, so you have 0 over 0 and you get 0, so the function is defined at 0. Well, that is actually one way of thinking about this function. I can also write this function as a product of two functions, that is 1 over x and sine x. Now you know that with 1 over x you get that division by 0, so we'll get undefined. So the function is actually undefined at 0. All right, but when we want to take the limit of the function sine of x divided by x, we don't worry about what is happening at x is equal to 0. All right, we want to take the values, we want to take into consideration the values of x that are close enough to this x. So we can actually make f of x as close as we like to a certain limit L by taking values of x close enough to what? Close enough to 0, in this case to 0. In the previous example, to 3. All right, so we can find the limit of this function, and because the function is undefined at 0, that does not mean we cannot find its limit. We can actually find its limit. So I just want to emphasize this point. All right, now that being said, I'm sure you guys now understand what limits are. Now let's get a little bit into details. Now let's start by looking at what are known as infinite limits. So what does it mean when we say that the limit is equal to infinity, or the limit is equal to minus infinity? So what does that mean? Now let's consider a certain function. Now let me just write it down for you guys. Now we take the limit as x goes to 0 of 1 over x squared. All right, so what is the limit of this function? That is the question. What is the limit of this function? Well, to help us understand what the limit of this function is going to be, let us try to see first of all that our function is not defined at 0, because we get that division by 0 again. So right now we don't want to worry about what is happening at x is equal to 0. Let's consider values of x that are that are close to this, that try to approach this 0. For example, if you say 1 is close to 0, you can also take 0.5, 0.8, all those values. So what is going to happen is, as I try to approach my 0 on the left side, what is happening? So let me just start with 1, and here we have our 0.5 and our 0.8. So the size of the value of the denominator, or the size of the denominator, is getting smaller and smaller. All right, and that means the denominator is going to be very small for values of x that are close enough to this 0. All right, so when the denominator gets very, very small, maybe let's take what value is that? We can take a very, very small value of x, like 0.000000001. So that is very close to 0. So the denominator is going to be very, very small. All right, and then the numerator is a constant, it's a 1. All right, so this is actually the idea of not settling down to a single value. All right, so the fraction, the overall fraction, is going to get insanely large. All right, so we don't settle down to any single value, to any specified value, like in the previous examples, for f of x is equal to x squared minus 5. So for this one, we don't settle down to a single value. Now what that means is we go to positive infinity. Now positive infinity is not a value like 4, it's just an idea. That means that our function does not settle down to a single value. That is, we cannot try to see to what value the function is going to go to. So we cannot try to observe that. We cannot observe that. We don't even try. We cannot observe that. All right, so that's what it means for us to have this infinity. All right, so now this is an infinite limit. Another good example I can give you guys is for the same function. Now let's take let's consider negative 1 over x squared. So what is going to happen? So same, it's the same thing. Now let me just rectify here. So what is going to happen now as we try to approach this 0 on the left hand side? Notice that the denominator is going to get smaller and smaller, smaller and smaller, and the fraction at each instance is going to get insanely large. So we are not going to settle down to a single value, but because of this minus sign, we say that our function is going to go to minus infinity. So same idea, minus infinity is not a value. So what this means is that our function is decreasing without any bound. So it's boundlessly decreasing. All right. So that is what it means for us to have these two guys here. All right. And now let me also say at this point that we can take what are known as sided limits. So we can consider left-sided limits and right-sided limits. For example, I can want to take the limit as x goes to a certain value. Let's call it a. Now a plus of a certain function f of x. Now let me just say that this is going to be equal to L. All right. Now the plus here signifies that we are taking the right-sided limit. So we are just considering values of a that are strictly bigger than the a. So for example, if our a is equal to 3, let's say a is equal to 3. So what we're trying to say is that we are considering values of x that are strictly bigger than this 4. All right, strictly bigger than this 4. And that is what is known as the right-sided limit. And now we can also take the left-sided limit by just writing this and trying to follow what this is trying to say. So here what it means is that we're considering values of a that are strictly values of x that are strictly less than this a. It doesn't mean that we're taking negative values or anything like that. What it means is that we're just considering values of x that are strictly less than this a. So these are what are known as sided limits. So you actually, so this is right-sided limit, and this one is a left-sided limit. Now this one is a left-sided limit. Now this is a story for another video, but what I'm going to say is the limit of a certain function. The limit of a certain function x is equal to the limit of a certain function. Let's call that function f of x here. As x tries to approach a, is going to be equal to L if and only if and only if the two sided limits are equal. All right, that is the limit of the function f of x as x approaches a from the right hand side is equal to the limit as x approaches a from the left hand side. So when this is when they are equal, and then that value is L. So it means that the limit as x tries to approach a, that is from the left and right side, is going to be L. So that is the takeaway from this video, or the takeaway from this part of the video. So now let me just the beauty of limits is that whenever we have these limits known, we can actually draw our graphs easily. All right, by first of all, let me define what is known as a vertical asymptote of a function. So whenever we have these situations, maybe the limit as x goes to a of a certain function f of x is equal to infinity, or maybe the limit of a certain function f of x is equal to minus infinity, or maybe you take the left and right left-sided limits. So let me just write all the 6 possibilities. So limit as x goes to a plus of a certain function f of x is equal to let's say is equal to positive infinity, and the limit as x goes to a minus of a certain function f of x is equal to minus infinity. Let me just use a plus here, and the limit as x goes to a certain value a minus, that is on the left hand side. So I'm just going to say a minus because it's easier than saying the entire phrase. So f of x is now here let's have positive infinity, and then the limit as x goes to a minus of a certain function f of x is equal to minus infinity. Whenever we are in these situations, now this means that x is equal to a is a vertical asymptote. All right, x is equal to a is a vertical asymptote. Now what that tries to tell us is that we can easily construct our graphs. All right, now let me just give you an example. So all right, so let's take a function x squared minus 5. All right, no, the limit is not infinity. Maybe let's consider the function f of x is equal to 1 over x squared. Now for this one, we know that the limit is going to be infinity. All right, and as x goes to 0. So what this means is that the y-axis is a vertical asymptote. All right, the y-axis is a vertical asymptote. Remember, we tried to take the limit as x. We were trying to take the limit as x approaches 0 of 1 over x squared. This evaluated to infinity. So what this means is that x is equal to 0 is a vertical asymptote. And now x is equal to 0 is another way of saying, we want to consider the y-axis. So because in the y-axis we have x is equal to 0, right? Yes. So the y-axis becomes the vertical asymptote. Now whenever you draw your vertical asymptote, well, you know what is going to happen as we try to approach that 0. Now from the right hand side, the values are going to get insanely large. And now for values of x smaller, all right? Maybe here we'll have the same behavior, right? Because we have positive infinity and all the values on the left-sided limit is equal to the right-sided limit and all that good stuff. So here, our values are going to, they're actually not going to touch the y-axis. They're going to continue getting bigger and bigger and bigger and bigger. So that is what we have there. All right. Now, I can give you guys another example. Now, let me just draw the graph of the function. Let's not worry about what f of x is. Let's just understand what I mean by let's say we have a certain function f of x, and what we are trying to do is to try and find the limit of f of x as x goes to 3. So as x goes to 3. Now, let's say we find that the limit of f of x, let's say we find that the limit as x goes to 3 of the function f of x, let's say that this goes to infinity. Let's say that we find that the limit is infinity. So what this means is that x is equal to 3 is a vertical asymptote. So I'm just going to draw this. Now, this is our vertical asymptote. Maybe let's say as we try to approach our function f of x from the right hand side, as we try to approach 3, that is our a, which is 3, sorry, not our function f of x, but as we try to approach our a, which is in this case equal to 3, from the right hand side, what is going to happen is this behavior. So we don't actually touch this vertical asymptote. All right. Another good example of this is the tangent function. Now you guys already know what we get with the tangent function, and I'm not going to spend time trying to discuss the tangent function. That is actually a story for another video. Now, I hope this video has helped you guys understand the idea of limits in mathematics, and I'll see you in the next one. Thank you.